Dear students, under the lecture series on complex analysis, we are solving problems under the topic Cauchy integral formula. Now, here we have a very significant problem to evaluate integral over c e power z divided by z square plus 4 dz, where c is the positively oriented circle modulus of z minus I equal to 2. So this means that the center of the circle is at I and the radius of the circle is 2. So now we have to evaluate this integral by using Cauchy integral formula. Now, in order to apply the Cauchy integral formula, we have to first of all rewrite this given function, that is, this given integral in this form: integral over c f of z by z minus z naught dz, so that we can apply this formula. And also, we have to prove that f of z is analytic inside and on c, and also we have to check whether z naught lies in the interior of c. If z naught lies outside C, that is exterior of C, then the integral will turn out to be 0 by Cauchy um, theorem. So now we shall first of all rewrite this given integral in this form, for which first of all we shall consider 1 by z square plus 4. We can rewrite this as 1 by z square, and then this 4 can be written as minus I square 2 square, because we know that I square is minus 1 and minus into minus will become plus and 2 square is 4. So plus 4 can be written as minus I square 2 square, and we are rewriting this in this format so that we can expand it by using a square minus b squared formula. So this becomes z square minus 2I square. So now we can write this as z plus 2I multiplied with z minus 2I. So now after rewriting it like this, we can evaluate this by splitting up it into partial fraction. So this integral, that is 1 by z plus 2I multiplied with z minus 2I, can be splitted up by using partial fraction, where we have a by z plus 2I plus b divided by z minus 2I. So from this we can write 1 is equal to a multiplied with, so cross multiply, z minus 2I plus b multiplied with z plus 2I. Now we have to find the value of a and b. For that, first we can put z to be equal to 2I. So that will give us 1 is equal to a multiplied with, what is 2I minus 2I? It is 0. Plus b multiplied with 2I plus 2I will give us 4I. So from this we get 4I b is equal to 1. So we get b to be equal to 1 by 4I. In order to find a, we can put z is equal to minus 2I. So from that we will get 1 is equal to a multiplied with minus 2I minus 2I. So that will give us minus 4I, plus b multiplied with minus 2I plus 2I will give us 0. So from this we get minus 4IA is equal to 1. So therefore we obtain a to be equal to minus 1 by 4I. So now we have obtained the value of a and b. So now we can substitute that over here. So therefore this value, that is 1 by z square plus 4, can be rewritten as, so this is equal to this value. So a by z plus 2I. So what is a? Minus 1 by 4I. So let me write that. Minus 1 by 4I multiplied with 1 by z plus 2I, plus b is 1 by 4I multiplied with 1 by z minus 2I. So we have rewritten this. Now let us substitute this in our given integral. So that is this is what we have to evaluate. So let us take and write this. So integral over c e power z divided by z square plus 4 dz. By using this over here, we can rewrite this integral as, so first this multiplied with e power z, so minus 1 by 4i integral over c, because this is a constant I have written it outside, and this is e power z divided by z plus 2i dz. Then plus 1 by 4i integral over c, so e power z divided by this one z minus 2i dz. So now this integral has been splitted up into two integrals. So this is the first integral and this is the second integral. Now we shall evaluate them separately and then we will substitute them here. So first we will evaluate this integral, that is integral over c e power z by z plus 2i dz. Similarly, we will also evaluate this integral. We observe that f of z is same for both. So first we shall check whether, now in order to apply the Cauchy integral formula, we should check whether f of z is analytic inside and on C. So that is the first condition. And the second condition is we have to check whether the z minus z naught that we have lies inside C. So these are the two conditions that we have to check. So what is f of z from here? So f of z is equal to e power z. We know that the exponential function is analytic everywhere. Therefore, f of z is analytic inside and on C. So, therefore, we have f of z to be analytic inside and on C. Now we shall consider the denominator of the first integral. And we shall check whether z naught lies inside or outside. So if we take this integral, we see that we have z plus 2i. So z plus 2i is equal to z minus z naught. So on comparing both the sides, we get z naught to be equal to 2i. Actually, we have negative sign here and we have positive sign here. So we see that z naught is minus 2i in this case. So z naught is equals to minus 2i. Now what is the given circle? The given circle is modulus of z minus I is equal to 2. That is, the center is at I and the radius is 2. So now here we have z naught to be minus 2i. We have to check whether this z naught lies inside, that is interior of C. So we know that C is modulus of z minus I is equal to 2. So first we shall see the distance between the center and this point. So how to find the distance? So we are going to check the distance from I, that is the center I, to this point minus 2i. So distance can be found by taking modulus of, so from we are going to find, that is the distance between these 2 points. So minus 2i minus I. So which is equal to modulus of minus 3i. So what is modulus of minus 3i? The real part is 0, the imaginary part is minus 3. So it is square root of 0 square plus minus 3 square. So minus 3 square. So we see that square root of 9, which is equal to 3. And we see that 3 is greater than 2. So 3 is greater than 2. So therefore, we see that the distance is 3, which is greater than 2. So distance between these 2 points is 3, which is greater than 2, which implies z naught equal to minus 2i. So this point lies to the exterior of C, that is outside, lies exterior of C. So it lies outside C. So that will imply that the first integral is 0 by using Cauchy theorem, because e power z by z plus 2i will be analytic at the point minus 2i Therefore, the first integral will be 0. And already I have told you. So, if it lies in the exterior, so if z naught lies in the exterior of C, integral over C f of z by z minus z naught dz will be equal to 0. So using this, we have found that the first integral is equal to 0. So therefore we can write that integral over C e power z by z plus 2i dz is equal to 0, because z equal to minus 2i lies in the exterior of C. So we have calculated this integral. Now this we will calculate separately. For that, first we will take and write z minus 2i. So z minus z naught is equals to z minus 2i. So z minus z naught is equal to z minus 2i. So on comparing, z is equals to 2i. Now we will find the distance of this 2i from I. Okay. So what will be the distance from I to 2i? It will be modulus of 2i minus I, which is equal to 2i minus I is I. So modulus of I. So we know that modulus of I is square root of 1 square, because the real part is 0 and the imaginary part is 1. So therefore that is equal to square root of 1, which is 1. And we see that 1 is lesser than 2. And we have the circle z minus I to be equal to 2. So the radius is 2. Therefore, we obtain 1, the distance to be 1, which is lesser than 2. So that will imply z equal to 2i lies interior of C. So if it lies inside C, then we can apply the Cauchy integral formula. We know that already f of z is analytic, because f of z is equal to what? E power z, which is analytic. Now this from z minus z naught, we have obtained this z naught equal to 2i to lie inside C. Now since those two conditions are satisfied, as I told you before, we are going to, because I told you that these two conditions has to be satisfied. So now we are going to apply the Cauchy integral formula for the second integral. Therefore, we get the second integral to be equal to integral over C e power z by z minus 2i. So that is the second integral dz. So that is equal to 2 pi I by the Cauchy integral formula. That's equal to 2 pi I f of what is z? That is z naught is z naught this is. So z naught is 2i. So f of 2i. So therefore we get this to be equal to 2 pi I f of 2i. But what is f of z? F of z is equal to e power z. So at the place of z we have to put 2i. So this becomes e to the power 2i. Now after evaluating the second integral, we can substitute both the integrals over here. So therefore we get integral over c e power z by z square plus 4 dz to be equal to. So let me write that. So this integral is equal to, first we have minus 1 by 4i. So minus 1 by 4i multiplied with, what is the value of this integral? We have got it to be 0. See, here we have got it to be 0. So that when we put, it is 0. And then plus 1 by 4i. So plus 1 by 4i multiplied with the second integral, that is integral over c e power z by z minus 2i dz. We have evaluated here. It is 2 pi I e to the power 2i. Now on simplifying, this fully becomes 0. And this here we will be having this I and I gets cancelled. And 2, this is 2 times. So therefore this integral is equal to, so what is that? We have 2 in the denominator, we have pi here, so it will be pi by 2 e to the power 2i. So therefore we have obtained integral over c e to the power z divided by z square plus 4 dz. We have evaluated this integral and we have found it to be pi by 2 multiplied with e to the power 2i. So this is the solution. So hence we have evaluated the required integral. I hope you would have understood this problem. This question has appeared in one of the previous year question paper. Thank you.